All right, so hello everyone again. This is Dinesh. We're going to look at the lecture 2 of this R tutorial for beginners. So yesterday we covered the basic ideas about organizing a project. We look at R Studio software, different panels inside R Studio software. That this one is the source panel where we type code and save it, store it. And this is the console where you can type any command or function directly. This part is the environment where the history and current data and objects we saved are available for access. This is where we can see what files are in the current directory and what are available to you for importing in R, and plot packages and so on. So basically you will work with these 4 panels most of the times, and then we cover what is a function and what is a variable. So these 2 words you need to really get good hold of and a good understanding about, like what is a function, what is a variable. And function is a set of instructions that has a name on it, and that takes an input and gives on an output, and variable is a pointer or a nickname for data stored in the computer memory. So just a trick that if you read our code, if there is a word that doesn't have a quotation mark around it, then either it is a function or a variable. R will throw an error if you type a name that doesn't have a quotation mark around it, and if it is not in data or a function. For example, if I type my name on it, it will say Dinesh was not found because there is no quotation mark around it, which means R thinks that word Dinesh either is a variable or a function in R memory, which is it not. That's why I throw an error. But if you put a quotation mark around it, then I will interpret this as interpret this as in a data, and it will take it as a character or a string data. So anytime you press Control plus L, so anytime you press Control plus L, it will clear off the screen so you can type more in the console. So now we will dive more into, actually from this point on, in our tutorials and whatever you will do for your project, it will be all about functions, different kind of functions, and then what is the input data. That's all you need to understand. And then that's all you will be typing here in the source panel, that I'm calling this function, that's the input data, and that's the expected outcome, and I'm expecting that outcome. So when you're trying to type a function name, our Studio provides a couple of handy tricks. So 2 key tricks there are using the tab key. So if you type a function name, let's say I type SQR, and it will automatically pop up that the closest function to this first 3 alphabet or character is SQRT. But you can also type you can also press a tab key and it will complete the function name. This helps because if you have a long function name, you don't have to type the whole thing. You can just press the tab key and it will give you an option and you can select it. And then second thing is, then if you press tab inside the parentheses, R Studio will interpret what parameters this function takes, and it will give you a pop-up window that, okay, what parameters are needed for this function. So using tab key helps in typing code in the console and also in the source. So that is just a trick when you're typing code. Now, where do I get the basic function? So I put a link here. This is a reference card. Oh, where'd it go? Yeah, this is a reference card. And it lists out several key functions basic function and a little bit of advanced functions that you can use in R. And I would recommend that you go through this reference card in your free time and try to understand what these functions are. Remember that when I told you the trick that any word before a parenthesis is a function, and so that way you can find that what are the functions. So you can see that there are so many functions written in this document, but these are basic functions that you will need them in your routine coding. Okay, so now we will generate some data. We will then use some of the basic functions on these simple data sets. So before we dive into data part, I want to give you 4 simple functions that you will need to install a package and to get help and to look at what's in my current directory. So now I asked you to make it easy for seeing what's in the current directory, but many times you need the file names. So for example, if you're importing if you're handling 10 Excel sheets, then you need name of those 10 Excel sheets in your R code. And this is where this function called dir, and if you type it, doesn't take any parameter. By default parameter is the current directory, and it will give you a vector of what files you have in your current directory. So now you can see the description, and I can see the description here, manual, and namespace. So this gives you a list of all the files that you have in the current directory. So that is a dir function. Now you can always save the dir function output as a variable. So here what I'm doing, instead of displaying the outcome of this command on the console, I'm telling R to save. So this is assignment operator. Save those output in our memory and give it a name file list. So now you can see in the environment window here that this variable file list has a value 1 to 7 element, and it's a character because all of them have quotation mark around it. So this is a list of all the files I have in the current directory, and we tell the R to store this output in memory and give it a name file list. So now if you type file list in your console, it will be that data that we just stored in our memory. So the next function is install.package. Now this is really one of the most commonly used function, and what it does, it basically takes input name of a package that you want to download from internet or the Crane repository, and you need to know the package name. So it cannot just use tab or anything, it won't work. So you need to type a name. Let's say we want to install our package, let's say curl, maybe not easy. So I just want to install this package. That should be installed. Packages with the extra S. Yeah. So always press tab. It's handy. It will give you that if there is any typo or if the function was not found. So now what we did, we just used the command install.package. Let me do control F. Yeah. So install.packages, and I given a quotation mark the name of the package that I'm interested in. So I say I want to download ggpubr, and then R basically checks the database on internet, and then it finds the package, it downloads it and install it. Now if you want to make sure that the package installed is actually working, the function for that is called library. And this is where you can actually use the tab key. So you type gg, and then it will give you the list of packages that are available for loading. So when I say ggpubr, and it will load it. So there was an error, and it will throw some warning message or some other message that there's no error, and we were able to load the library ggpubr into memory, and it's available for use. Now if you say that, okay, what functions are inside ggpubr package, and you can say question mark, actually go packages, and so you need to go on the right side packages and look for the package ggpubr. It's here, and check means it's loaded. And now when you click on ggpubr documentation page, it gives you a list of all the functions that are inside this package and little description that what the function does, like add summary, it's add summary onto a ggplot, annotate figure, annotate arrange figure, and so on. So these are all handy functions inside this ggpubr package. Now I would say there's not a single person who knows all these functions except the developer, like on the user side. Most of the time you will be using one or two functions out of this package. For example, making a bar chart. So in this package we have a function ggbar chart somewhere, ggbar plot. So when you click on ggbar plot, it will give you another function. So this is the function before the parentheses, and these are all the parameters that it can take from here to here. And so that many parameters, basically it helps you to customize a bar plot. That's why you have so many parameters in here. So that's how you install a package, you load a package, and then you can look at that what functions are inside that package. But usually you don't click, usually when you search such a package name on internet, you will get the function name already, that what functions I am interested in inside that package, because you don't want to learn the whole package. You are interested in some useful function inside that package. And next function is called help. So for help, it's simple, like you type help and then you type ggpubr, ggbar plot, and then it will take you straight to that help topic. So you type help and I want to know about this function, and I'll take you to the documentation page of what the function does, what are the parameters, and it explains that what parameters actually means, the type, it's a character, numeric, all that. And there are many times a good documentation will have example data, and these example data you can actually run them as it is on your screen. So for example, if I would run it, you can try it out. Let's try this guy. So these example here, you can run them as it is, and they don't need any other coding. You can literally copy it and run it, and it will show you how the test data look and how the function work. So that was, we got the directory, that what's in my current directory. We can save what's in my current directory as a variable file list. Then we can install packages from internet from our package database. Then we have our library command or function that load the downloaded package, and then we help on getting documentation for a function. Now in R, everything is a vector, and so vector is a collection of items. And everything is a vector by mean that that's how R work. R put all the data in a vector format, and that makes it a powerful language because you can do a lot of vector operation on the stored data. So by vector I mean that here you have this square bracket 1 to 7, which says that we have element 1 to 7, and so that is the vector here. And to make vector in R, you need a function, and it's just C. That's a function in R. So C is a function. And so if you type $C, and it will give you combine values into a vector or list. I'll cover list later, but let's talk about combine values into a vector. So it puts input inside the parentheses of C function into a vector, into combine into vector. So what I mean, like, okay, that's how you use it. I want you to type the simple command with me. Whenever you see a command or a script I'm typing, please type it on your RStudio screen. So let's say we want to make a vector C, and it has only one element, and I type 1. So that is a vector having one element, and its number 1. I change it to 5, and that is the other vector of one element. It has one value 5. Now you say, oh, can I save it as a variable? And like, definitely. So we call it a one element, and we say C5. And so this is one element. So you can store this one element vector as one element variable name, and then you can access it later. Now you can make it let's say 5 element. We again type C, and then we provide 1, 2, 3, 4, and 5. So now our element, the second vector, 5 element, has 5 elements. So that's how you create vector in R, that you need to type these values after the parentheses. Again, basic concept, the numbers do not need quotation mark, but if you put quotation mark around that, they become characters. So if I put quotation mark around any of the numbers, all of them will become character. So because when create vector, it will convert them into same type. So if you say I have one element as a character because I have quotation mark and other are number, I cannot handle it. I cannot treat them as number, all of them. So that's why it will convert everything into a character, and that's why this variable 5le has become a character vector. And so other way we can have character vector, we can call it word vec, and let's say it is RStudio. So if you can have similarly one element or more than one element in a character vector. So word vec is it's a variable name. It has an assigned value of a character vector with 2 elements, RStudio and RProject. And so that we can see here, word vec, character vector, 2 element, 1 to 2, RStudio and RProject. And when you type word vec, it will give you the value back. So that's how you create vectors in R. Now I want you to remember that in R everything is a vector, and it's a vector language. Whatever you type in, whether it's a one value or n number of value, they all goes in vector. From vector it gets transformed into different types, but the starting is always a vector. Now you can always create, it's called sequence command, that I want to have 1 to 10, then it will create a sequence of 1 to 10. or 1 to 100. So that's the other way you can create a vector by using sequence command. Then the third function that create vector is called repetition, that I want to repeat x 20 times. So it will repeat x 20 times. So that's a third way you can generate data in R. These are helpful, like repetition is helpful when you are creating, let's say, labels or categorical variables where you need to repeat, let's say, cases or control n time. Then you can use repeat case 6 times or control 6 times. Then you can the repeat function is helpful. So I covered basically that how we can create vectors. In R, everything is a vector, and we can display the vector data. If you run them directly into console, it will display the data, or you can save them in our memory for later use. Actually, it's fine. All right. So I want to delete all of the previous objects. So we click on this button. This is clear object from the workspace. It empties the workspace. So now we will start create a vector with one numeric element, and we call it, let's say, A, and we say C, and we give it a number, let's say 56. Okay. One character, we call it B, and we say C, and we call it RStudio. So I'm just creating some data that we will use in these different functions that I'm going to teach in from line 72 and so on. So create a numeric vector of 10 numbers and store it. So we call it AB or A10, let's say A10. C, and we say 1, 3, 5, 7, 21, 22, 34, 56, 78, and what's this? Oh, it got 11. I want to have 10. Okay, so A10. We make a other vector that has a length of 10 number, but some overlapping number. So we change some of these numbers. So we call it 2, and we call it 8, and instead of 22, we say 25, 57, 58, 8. I'll keep that. Okay. So here is one vector A that has only one number, vector B that has a one word RStudio. A10 is another vector that has 10 numbers, and B10 that has other 10 numbers. Some of them are same as A10 vector. Let's create cities is a other vector where we can put town names. So let's type some simple town name like Delhi or New York, Chicago, Jaipur, Boston, Houston, Paris, Geneva. How many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's try one more. Milan. Okay, so these are 10 cities, and we have 10 words. So we call it city vector, and then we always type that, let's call it cities, and we type it a B, and we change some of the town with other names, let's say LA, and change Boston to Seattle, Amsterdam. Okay. All right. So we have two single element vectors A and B. We have two 10 element vectors, numerical vectors, and we have two 10 element character vectors. And you can see all of them here. So A, it is a vector with one element, B vector with other one element character, then A10, oh we didn't type the B10, so B10. And then we can see B10 and then cities and cities B. Okay, so now these are the things we type in our studio, and now we are doing a training, that's why I wanted to type in. But normally you don't type in, you import data directly from an Excel sheet or CSV file or TXT file. And we will cover that part, that how do you directly import this. But for the training and basic understanding, it's important that you understand how vectors are created and how we will take these vectors and build other data objects. So the basic operation that you can apply on all type of vector, whether it's a character or a numeric, are listed here. There are many more, but these are the some that I use it, or you will commonly find them. Number one, if you want to test is vector, so you test is vector A, it's true. It's a single element vector. Is vector B, it's also true. So that's how you test if this data you store in the memory is a vector or not. Now you say is character. So if I say A, it will give false because we know it's a number. And if I say B, it will say true. So this is a function to test if it's a character or not. Similarly, if it's a numeric, and A will be true and B should be false. Okay. Then we want to know how many elements we have in our vector. The command or function is length, and we say A1, and we say A10 has a 10 length, and B10 has a 10 length. So length is it's a commonly used function. You will need this in many places. For example, if you import a data and you want to know the number of elements in column 1, then you will use length function to get that. If you don't know the type of your input data, you can always use this function called type of A. It will say you double. So in numeric we have different type of numbers, and by default it will save them as a double numeric. And if you say B, it will tell you character. B10, it's double. We say cities, B, character. So by using type of function, you can get what type of data are stored in that variable. Now unique give you if there are duplicates in a vector, it will remove that duplicate and give you back only the unique value. So I don't think we created unique values. So let's say we create a vector city C and we repeat Jaipur twice. Okay, so I have Jaipur twice, And so now I say cities C. First I want to see the length of it, so it should have 11. Oh, yeah, 11, because we added Jaipur here twice. Now we say unique. So now you can see that Jaipur was double and it removed it. That now it's occurring only once. And you can type length around it, it will give you the length is 10. So an output of a command or a function can be input of a other function. So here what I did is that I asked R to do this inner calculation, and then whatever the output is, just use that as an input for length function. This is called chaining. So you can inside the parentheses you can put other function and input, and the output of that inner function will be used by input for the outer function. And RStudio will make sure that all the parentheses are matched, and if they are not matched, it will throw an error. So that's how you remove a duplicate, and you get only the unique values. Now sorting is basic, so you will sort. Let's say we wanted to sort. Well, that they already sorted. We can sort the cities B, and it will sort them alphabetically. So you will start from A, B, C, D, and go up to Z. Sorting gives you a sorted vector. This is helpful when you are doing data sorting and or doing some sort of summarization for reporting. Now order is also sorting, but it would not give you sorted vector. It will give you the location, that what element should be the first one, and then what element should be the second one. So in this case, Amsterdam was 7, located at 7 index in cities B vector. So order will give you that what element should be the first, second, third, and fourth. It won't give you a sorted vector. Now intuitively we can say, okay, that means I can actually use the outcome of, now I'll cover that later here. Now next function is called which takes a vector as an input, and then you can type a Boolean or a logical command. Remember the symbols I explained you yesterday. So I put those symbols in this Google Doc at lecture 1 summary. So I try to summarize that, what are these symbols, logicals, and some other symbols. So remember, you have a logical that 2 is less than 3, or 3 is greater than 2, and so on. You can use these booleans in which command, which function actually. And we can say which of A10 is greater than 4, and it will give you the location of those elements, those are greater than 4. This is helpful when you're trying to do simple data filtering or subsetting, that I want to have all the people greater than 50-year-old. You use the which command, that which age is greater than 50. I'll give you the location of those data. Now all you're getting is a location right now. How do we get data from those locations? We will cover them into the next part here. So which command gives you the location of data that passes the Boolean, passes the logical test. So here in this case, whatever element in the A10 vector are greater than 4, provide the location for those elements. And so you can also say, like I can use any other logical one. So I can say A10 equal to 3, and it will give you the location that which of the A10 element is equal to 3. You can always combine that if it is 3 or it's 4. So you can combine two conditions inside the which function and still give you, because we don't have a 4 in this vector. So if you type A10, yeah, there is no 4. So it will only give you one element location, which is number 3. But if I say 5, it give you 2. That either it's 3 or 5 at location 2 or 3 in the A10 vector. What reverse does, it basically flips the order. So if I say A10, it flips. Instead of starting from 1, 3, now it will say start from 345, 78, 56. So it flips the entire vector. This is handy when you totally want to like reverse the order of some task. Instead of starting from the top, you want to start from the bottom. That way you do it. You can reverse a vector. Length is already covered. Sample basically takes a vector and you can type how many random samples you want out of the vector. So basically here we provide A10 as an input for sample function, and then it takes a second parameter that how many randomly selected element we want back. And so this, if you run it again, it will give you different 5 element. If you run it again, it will give different 5 element. So every time you run sample, it will give you n number of randomly selected element back for an input vector. Names, so vectors can have name, elements can have name. So right now we are pointing elements by their location, like element 1, element 2, element 3, and so on. But they can have names. What I mean is you can provide names for each element, so that way you don't need to worry about the location. You can give them names like age, BMI, height, weight, or any other phenotype or any other variable name. You can give them. Let me give you a demo. Like, so my health has, it's a vector of, let's say 50, well, I'm not that old, okay, 38, my BMI is, let's say about 22, my height 180, yeah. So this is my health, and now I can give names, names my health. Our other vector, it's age, BMI, and height. So now if I type health, you can see that now all the elements have a name on it, that age, BMI, and height. So in a vector, elements can have name. Why it's helpful? It's helpful because when you have a really long vector and you don't know the location of the data you want to get back, so you can just use the name to get the data back. And this is where the $sign comes. So $sign is exactly for that purpose that we don't know the location of interested element, you can use the dollar sign to call by its name. What I mean is, you type my health, then dollar sign, and you press tab. No, it should. Oh no, a dollar sign doesn't work for vector. Sorry, ignore the dollar sign. That's something new for me. The dollar sign works for data frame and list. It doesn't work for vector. But to get, you can use like that. So this is where we're going to cover how do we access data inside a vector. So x n with n element. So if I want cities and I say element 1, it's Delhi, or element 2, it's New York. What I'm using, it's this square brackets. So square brackets is useful that the number or vector inside this square bracket, it shows the location of data that you want to access. So you can, and a word before a square bracket will be a data. It won't be a function, it won't be any other thing, it will be always a data. And you're trying to access data inside, specific data inside that data set on a particular location. So if we don't want, let's say, the last, or we don't want number 3, then it will remove the number 3 element. If you use the negative sign, it will remove the number 3 element and you will get all the other one back. And if you say cities 1 to 4 only, so then it will give you only from 1, 2, 3 and 4, and it will not give you 5 and so on. You can also do the same thing, that I don't want from cities 1 to 4, then it will give you the remaining one. It will remove the cities 1 to 4. So you see that I use C here to create a vector, and that is a sequence of 1 to 4, and then I provided that as with a negative sign, that now I don't want those values, the cities from 1 to 4, and give me the remaining one. And if you want to have specific one, that I want to have only not the sequence, but 1, 3 and 6. So that's how you get the specific one, that you need to provide the values as a vector inside the square brackets, and then it will give you those specific values at those locations for that vector cities. And now if you have a vector with names, this is where you use this command, that now I go with my health and I type that I don't know the location of this element, but I know the name of the element, that it should be age. Then you can type age here and it will give you back the value inside that vector. You can always do that A10, give me all the A10s that are greater than, let's say, 5. So this is where you use the logical test that provide return all the values that are greater than 5, then you basically provide a logical test inside a square bracket and will return you those values that pass this test. And so this logical test could be anything, like you can combine multiple one, you can have use greater than, less than, equal to. So in this case we're combining that, and it should be less than, greater than 5, and less than, let's say, 50. So it will not gives out 56, 78, and 345. So that's how you access element inside a vector using square brackets. So anything in the square bracket, it will be a location. It will pointing toward a location, whether you're generating location by typing the exact location number, or using a name, or using a logical test that whatever location is true for this test, give me back. And so those are three ways that you type exact location numbers. You can use the name of the location, or you can use a logical test to get back those elements. Now, up to this point, all the functions can be applied except these two. Up to this point, yeah. Up to this point, all the functions can be applied on all type of vector, whether it's actually there are only two type, character or numeric. So you can apply on all these two type of vectors. Then there are so this I should actually put it here for numbers. And so there are specific functions that you can only apply on numerics. So for example, which max, and we say A10, it will give you the value that 10 is actually, element 10 is the max one. So you can see that in my A10 vector 345, which is located at location 10, which is the 10th element, so that's why we get the value 10 back here. And which mean A10, my keyboard is really small, so, and which mean we are asking that in the A10 vector, where is the minimum value located, and that is number 1. That the value is actually also number 1, but if you have more complex vector, it will give you the location of the minimum value in the vector. If you want to have the actual value, well, in this case it's actually 1, that's why you see value 1, but if you say max, which is second command, then you see 345. So when you say which min or which max, it will give you the location, and if you just use max and min, it will give you the exact value, that what value is actually the maximum value or minimum value in the vector. And then you can do sum, that I want to sum entire vector. It will basically do addition of all the elements and give you the total value back. You can also do log, that I want to do log of every number inside one vector. So this is what I did here. It's called Vectorized Operation. That in R there are functions that you can apply on every element inside a vector. So with what we just did, that okay, we want to take a log of every element inside the vector A10. So you don't need to write like a complex for loop or other apply function. There are inbuilt function that takes vector as input, and they will do logarithm of every element inside that vector. Then we have a scale, which basically can transform the data into the default scaling. And if you want to know what is the default scaling, you can read here that it does the center. So it's it takes the maximum value and then it will scale according to that. The next function is diff. What diff does, it takes each element, then it subtract from the next one. So it provides a difference between one element and the next one, and so on. It will repeat it until the last element is reached. If you want to convert your numeric variables to numeric vector to a character one, the command is called as character. This is helpful when you're trying to put labels or when you're trying to create factor or categorical variables. You can use this as character command to convert numbers into characters. So this was all about what do you do with both type of vector, number and character. What are the things you can do with numeric only vectors. Now what you can do with string vector or character vectors. So we call I put some of the basic functions that you can do with strings in R or character data in R. And number one is paste. What paste does, it basically, you can combine two words together and it will make a single word. For example, you can have let's say R studio comma R. Studio R. So it puts a space in between and then it will give you a single word. So that's how you combine two words. And then we have a substring that if you want to have a part of your word extracted, so we type substring and we type studio and then we type, I'm actually looking at the documentation same time that okay, substructure, it takes an input and then you need to provide start and stop. So let's say I provide start at 1 and stop at 4, then it will go from STUD in the studio word and will stop there. These are helpful when you're trying to create dynamic data or extract. Let's say you parsing an identifier and then you want to parse only the first 4 or n number of characters because those are the useful one. Or if you want to parse, let's say, year from a date. So we know that year will have only 4 numbers. So you can use this substr function to get those 4 numbers. So what graph function does, it takes a pattern that I want to test if stud is present in studio word studio. So here it takes studio as a vector and then it tests if stud is actually there, and we can see that yes, stud is there, STUD, and it will give you that yes, on the location 1 stud is there. And if I say okay, that's element 1 and I want to see if So now you see that this, yes, it found stud, which is a substring pattern at location 2 inside Studio Word. Now if you change the pattern, like, okay, now I'll just say stud1, it will say integer 0 that it couldn't find it. So that's how you search inside a string, and this is called grep function. And you can look at different ways you can use this function, like ignore the case, or you can have Perl enabled or fix use byte. To learn more about these different parameters, you have to scroll down and I will explain you what these parameters mean. Now I won't go in detail because this is just project specific. Like some project you need it, some you don't. But that's basic, just to give a basic idea that how do you match string to other string. Now you can say also that, okay, can we do the replacement, that I want to replace something with some other words. So you want to replace stud with, let's say, R stud, or stud with TTR. So that's how you do replacement, that G sub command takes the input pattern, that stud is the pattern that you look for, and replace it with TTR value. So it will basically go through the vector. If it finds a stud, it didn't find an R project word, so it will not touch it, but it did find in Studio Word, so STUD, and what it does, it just replaces that word with TTR, because that's what we provided. So that's how you do replacement in a string value. Then how do you replace values that matched the input criteria and then replace with the provided value? To lower, it's simple, as in, like, if you have all caps, it will convert them to smaller letters. This helps in because R is case sensitive. This is helpful when you're trying to merge data from different sources, and then one source is using the first alphabet letter as a cap and other is not using it, then without using this command, you don't know that data can be merged. So my recommendation is always use lowercase whenever possible, and I would say avoid uppercases at all. You try to use lowercase as much as possible. Ncar is number of character inside a, so it will give you how many characters we have for each word for cities vector. And you can always have just one input, so you can have one word input and it will give you how many characters we have. We have 6 characters for Studio Word. str split, that basically takes a word, let's say R Studio is awesome, that's the string, and we say split by space. So then it will give you a vector where each element was generated by splitting this sentence at space location. So, and you can have this split here. It could be a comma, it could be a pattern, it could be a word, or anything. But that's how you split strings into different elements. Okay, so I got 1 minute left, and actually I explained that vectorized operation, that there are functions that you can apply on every element inside a vector, and that's what makes our powerful language, because these vectorized operations are optimized for speed and for memory efficiency and a lot of other things. So if you have a command or a function that is already vectorized, you will get a lot of speeds compared to a traditional for loop or a traditional while loop. Now, I don't have time left to cover the data frames. We will cover them in tomorrow when we will import a data file and do basic statistics. I will cover these three things, a data frame and matrices, and then we will do statistics direct on them. So I'll end today, and if you have any question, you can ask me in the comment section of this video, and I'll try to reply. And tomorrow we will cover data frames, matrices, and do some basic statistics with those data sets. Okay, so you can I'll give you a little homework, which is like go through this reference card. The link for the reference card in the Google document here. I think this is the first one. And you can also go through these different websites I put on this Google Doc. And you can find functions. Remember, you're looking for functions in these documents. So you want to look for the words before the parentheses. That what are the cool functions or powerful functions these people have described, and then you want to use them in your projects. All right. With that, I want to say bye. I'll see you tomorrow.